Hello, live testing. Uh, can't wait. Hello, nice. So, we have a couple of moderators who will be joining us. Uh, for the folks who this is the first time experience for us also. So, in case we get it wrong, just let us know. Uh, can you see the stream well and clear? And nice. Thanks, and thank you, Kevin. I hope I did not mess up your name. So we still have 10 minutes to before we actually start. So the idea is just let the doors open and let people come in. And so the moderators that we have today, we have Amit, who will be sort of moderating the questions. And since I actually get a delay of a few seconds, it's for what we tested is around 30 seconds, or 30 to 60 seconds between what I'm saying to what the chat comes to. So that's why we need moderators in this setup. And I'll be pausing a lot during this session just to make sure we don't miss out on questions or hey, grab a cup of coffee. Uh, about yes. So the way I do this is generally I use Jupyter uh, to sort of create the slides. Yeah, Rise is the library that I use. So it actually converts a Jupyter notebook to slides, and it's sort of helpful if I want to show code also and visualizations. So I just generally go with this setup. You can find most of the things on GitHub. Well, the slides and the repo, and yep. Also, the slides are available at my github.io in case you want to follow while using the slides. Oh, the setup seems to be working. Sort of happy about that. Yes, Karan. We have still 5 minutes before we start. Mm, ouch. Uh, hmm, interesting. You shouldn't be getting the error mostly. Uh, hmm, let's see what it is. That seems to be working for me at the moment. But we'll share. Hey, Karan or Amit, can you share the slide link with everyone? Maybe on the meetup messages. Uh, Priyank, this is Firefox. Oh, awesome. It might just be GitHub.io, not used to having these many visitors on my page. Just kidding. Hello, Samarth. And for people who are wondering why there's like a half screen, is well mostly because I wasn't sure how the moderation is going to work in YouTube. This is the first time trying it out. So what I've done is, well, I took three-fourth of my screen as the browser and one-fourth as the chat. So I can follow up on questions directly here. Well, all right, let's do a quick check of how many people are here. Cool. We have an audience. Nice. Yes. Uh, It's it's sort of fun that you can do this also. Well, recursion has its limit, at least in Python. All right, we are 1 minute to start. So, by video, do you mean the stream link? All right, it's 7 p.m. And well, let's start with the session. Roots and me. Hello. All right. So, well, while we give some time to people hopefully to join in, I know the link and all is sort of new and it's hard to like actually check the links and everything uh, at the right time. So let's start with a company introduction. Oh, thanks, Emma. Uh, well, I work at Sahaj. So Sahaj Software is an organization or a company that, well, we work in the service industry. We sort of like to pick projects that are interesting to do and sort of challenges us at by different angles. Recently, we have been doing a lot of distributed data. Sorry, chat is slightly distracting, but ignoring that fact. Yeah, so we have been doing a lot of projects on distributed systems, and now we're doing a lot on the machine learning side and a lot of data intelligence systems, and that's how the whole idea of this talk sort of stemmed out. Is we want to talk about what are the bad parts, how we saw in our experience things start getting ugly, and how we sort of came up with a few solutions or rediscovered some of the solutions that already existed. Uh, and but what are the key concepts? That's what we're sort of gonna talk about. So, uh, yes, we can. I don't mind waiting. Oh, I can also click on recording on my local. Should we wait for another 5 minutes? Start at 7. Okay, make it 10, then 8 minutes. We can start at 7:10. If everyone is okay with it. In the meanwhile, if someone wants a coffee, please go ahead. Oh, we have participation drop. Interesting. Ah, all right. So yeah, I'm sort of not the best person to do all these introductions, but I'll talk about a bit about DevDay. So DevDay is sort of a concept that we came up with. Is you wanted to have a platform where the dev community sort of can talk about different topics uh, and sort of share. It's not limited to one company. It's just an idea that we sort of want to put into the wild. And Dev Day is what we call it. So it's just one day where we come together, talk about different topics, we discuss. Uh, Generally, most of the setups we have done so far have been uh, offline, well, offline and recorded and streamed. Uh, but it's always in an office, so it's easier to sort of do the discussions part, which is not possible now given the current situations we are in. And so DevDay is sort of a idea where we say, hey, let's talk about the solutions that we are building. Let's talk about the concept, and hey, yes, and the way we do it at Sahaj is we do it as a monthly event. So we generally try to do every month one session for the community. And yes, we have sort of taking this global now in multiple ways. Like we have three. Oh, sure. Uh, yes, we are global now with the stream in a way. Uh, so we have people from three different offices and well, across and wherever people are at the moment at their homes. And yeah, we are international also in a way because well, I'm stuck in a different country right now and you can't travel. This was this better? Sound check. Should I be more louder? Yes. Yeah, thanks. All right, I'll try to keep my volume at this. Hello, Nipim. And sorry if I butcher someone's name. I probably don't know how to pronounce all of them. And yes, correct. It's just yeah, it took a lot of time. Yes, anyone from outside can present in a dev day. You can just send us an email with what you want to talk about, and we can arrange a session for you. All right. So we are gonna wait for another 2 minutes, and then we're gonna start. Um, from my perspective, it's anything to do with technology, as long as it helps the dev community uh, with the work that they're doing or things that they're trying to learn. I think it is acceptable. Roads and me. Any other questions or any other parts that I might have missed? Yeah, I mean, you can talk about editors if you want to. I mean, editors are fun, I guess. Uh, no, Nipam, this is not specific to database technology. These are just concepts that we've picked up while doing different data projects. Uh, so the way of structures talk are not limiting this to technology. Most of the things that I'll be sharing are just concepts that anyway, you can replicate in any of your projects. Whew. It's 7:10, and I think we should start now. Well, we have only 5 people, sadly, but that's okay. Yeah. Well, it becomes a lot easier if you're in a room with full of people. Yeah, I agree. Or probably if I had a better mic, that would have also helped. Awesome. So let's begin. We still might have people joining in later, which is okay. Release this, sure. All right. So the topic of the day is the data, the bad, the ugly, and the tamed. So a little bit about myself. I've been part of the well. Karan, I cannot see the comments, so I cannot really answer any questions that way. If we do that. Oh, thanks, Katale. Yes. So about me. Well, I my name is Jayant, and I work at Sahaj. Okay, let's do that then. Hey, we are at full slides, and I cannot see you. So good luck. All right, about me. So my name is Jayant, and I work at Sahaj Soft. I've been part of the data ecosystem for approximately last 7 years, and I've worked on different technologies, so ranging from data visualizations, machine learning, to just basic data wrangling and data mining. And I have worked with different set of companies and nonprofits. The nonprofits part was interesting, which we can also talk about later. And so, what the agenda of the talk is going to be about. We're going to start with why we need to talk about data, and then we're going to try defining what's bad data, what's ugly, and some of the concepts that uh, helped us taming it. So, starting with why we need to talk about data. So, if you think about it, most of the data science projects that you might do or have done, they all revolve around input data set, data mining exercises, and then a model that sort of maybe does a classification, for example. And if it's a classification, what that model basically is doing, it's sort of given a row of data, it's generating another data point for you, which can be anything that you want to classify into. Now, so that's where I sort of like to say models are just functions that sort of process, transform, and generate more data. And I think for any data science project, that's why it's always important to talk about data. And your models, well, given that everything revolves around the data in a data science project, your models or any project that you do is only as good as the data that goes into it. So it's similar like garbage in, garbage out. And so I'll stop for quick comments. No, awesome. Uh, so what does bad data look like? Right? It's so hard to define what bad data looks like because if you think about data, right, you have so many different kind of formats. For example, images, right? Images, you cannot tell whether they're good or bad until you actually look at it. Uh, then you have tabular data, which is slightly easier than images. Then you have sound data, which is complete different beast in itself. So rather than answering what bad data looks like, I thought it would be easier to figure out what good data looks like. And so this small list is just based on my experience. Uh, the good data that you have should be machine readable. We should know from where it's coming from, what kind of attributes it has. By attributes, we mean what kind of data it holds, whether you have whether you're dealing with stocks data or are you dealing with sound. You sort of need to understand what kind of data you're dealing with, uh, and you need to understand how you sort of, if you apply a function over your data, what kind of changes it might bring into the system. And last and sort of the most important is the data should be usable, because if it's not usable, it's not really good data, is it? So, what I like to say is all data are bad. I don't think there is any good data. You just know some data sets just do well, and we know how to treat them. Another way of putting this is all data are bad unless proven so. There's another thing sort of that goes around. So, quick pause for questions. Not really. Uh, so, let's sort of define what ugly could be, right? And in my experience, when you start to take the bad data, which is probably something that you don't understand, maybe you haven't spent enough time analyzing it, and you put it into a data mining project, and you just say, hey, we know this works, and this is how you can classify it, uh, and you just put in the data, and your results might even look okay. I mean, you'll be surprised if it does. But if something breaks or something happens, you we wouldn't even know why it happened, and that's where sort of it becomes ugly. And there would be cases, and most of the projects you sort of have a stream of different pipelines that takes one input of data, processes it, pushes into another pipeline, and it sort of keeps going down and down the chain. And if you don't understand the data, uh, it's gonna be really ugly once you start facing problems. And the kind of problems won't be simple bug fixes. It would generally be the data that you're coming in with is wrong, or your client might say, hey, this output does not make sense at all. And that's why it's really gonna get ugly. And since you don't understand the data you're gonna work with, it will be hard to answer those questions. So, before we go to the taming section, any comments or anything, any questions, or anything that you would like to add? I see Raja adding it. Uh, well, I would say yes. Even the most structured data in AWS, in the context of data science projects, can be bad. Yes, if you don't know the kind of data that you're dealing with, the output that goes to the business or the clients might not be useful at all. So in that sense, you would sort of have bad data. Hopefully, I'll cover some of the examples in that way. Yes. So, if you look at the definition of what a model is, right? A model or a data pipeline, they do essentially, on a higher bird eye view, it does the same thing. It processes data, it transforms it to some other data, and you basically end up generating. You basically models, you generate more data. Now, how do you sort of make sure that the data that you're generating is good? Thanks, Karan. And well, we can talk about ugly if you have any specific questions uh, later on. Cool. So, what does sort of taming bad data look like? And we sort of might not talk about taming ugly data here because the concept of ugly data is that the assumption there is that you already taken bad data and push it to uh, your pipelines and it sort of becomes uglier. And so if you tame the bad data, you possibly would not get into a situation where you're dealing with ugly data at all. That's what my experience has been so far. It can be proven wrong. I'm pretty sure about that. But when it comes to that, we'll talk about that. So, taming bad data Kaggle style. So, if you're not about Kaggle, Kaggle is actually a website where you sort of it hosts competitions on data science projects. It's sort of a good way to learn more of different data science techniques and get become more aware of the kind of data sets, the kind of problem statements that you can solve, and so the general process of what it looks like is you read the problem statement, you understand what the understand from where the data is being generated and the kind of problem that you're trying to solve, and then you start analyzing your data. You sample it, you analyze it, you figure out what kind of pre-processing that want to do with the data, and then you create a model, validate it, and then you click on this. You push your results to Kaggle, you submit your results, and you get a feedback of what's your score on the leaderboard. And that whole process sort of keeps on reiterating. Like keep on creating more features for your data, you pre-process it further, and you sort of keep on reiterating that. But that does not work in terms of uh, real projects. Uh, so the problem with real projects, difference in a Kaggle style project and a real project would be the major difference is the data itself. Uh, in Kaggle, you would get a clean data set that sort of works for you, for the problem statement. And actual projects, you don't uh, get the data. You get most of the data for not in a format from which you can actually solve the problem. So you always have to do a lot of transformations to make it viable to solve a problem. And the sort of steps that you go while taming bad data within projects is first is your data analysis project, data analysis part, where you sort of figure out whether you can solve the problem that your client or the users want to be solved. And then you create a pre-processing pipelines, you transform it, then you write test flight transformations, you store the data, and you sort of go to multiple different iterations of having one pipeline do one thing, then another pipeline do another, and you sort of automate the whole process of reaching one start where you just have data to uh, end where you are able to help your uh, client or your users with some kind of data analytics or uh, may assist them in some kind of work that they are doing. Is everyone with me till now? Cool, I don't see any questions. All right, so data pipelines, right? What could possibly go wrong? Like, so just to explain what can possibly go wrong in a data pipeline, we are going to take a simple pipeline that basically takes multiple different data sets and it does only a join. And the assumption is that you've already written tests for the at least the operations that you're doing, because then it sort of goes into engineering side whether how you should be writing tests. We are not discussing that part. The assumption is that you actually have written tests. If you have not, probably that's the first step that you want to do. So basically, the first thing that how you would do like to do the join, right? You would start with sampling the data. Let's say you look at dataset 1, you look at dataset 2, right? There are only 3 columns. There is ID, there's column A, there's column C, and there's nothing much. Uh, you basically want to do a join, and after join you would probably get A, B, and C. Now if you join is simple enough, you're basically adding one more column here. Now the problem is these actually have and let's say you sort of figure out, hey, uh, you don't actually need the rows that have nan values in column A because it's not adding any value. So you maybe, let's say, remove it, for example, because which is sort of a drop NA. It's a hypothetical case. You might not even do that. It depends completely on the business case, what you actually do with that. But let's say there's a third data set now where you have a lot of nan values for A, and if you sort of do a join with it and do a drop NA, you sort of lose out a lot of data. Basically, you lose out on all the values that are coming in from the data set C. And this is like a very basic rookie mistake that we all end up doing at one time or the other. At least I've done it initially. Uh, and we were actually dealing with PDFs. We were passing PDFs to convert them to tables, yada yada yada. But what happened was there were around 300 different PDFs. We looked at a bunch of them randomly, and they all sort of be in a similar structure. And we built the algorithm. We spent 3 months building the algorithm, and it turned out it only worked on like 10-20% of the data, which was sort of a setback. And you sort of uh, end up doing things like that. And the faster you learn that you need to better sample your data, the better it is. Uh, so this another sort of example that I want to pick on the sampling side. Uh, so that problem, okay, the previous problem is actually solvable by a simple thing of like, hey, just look at the data, right? Look at it more carefully. Maybe just not sample it, just look at the whole data set and it will work out for you. But there are cases where you sort of have different data sources keep adding on. Uh, let's say you are processing a different stream of data sets coming from different sources, and you club them, bash them, and you put them. And there's a new data source provider that you might want to add. And let's say it has the same ID column, then you have the D column and F column. And let's assume you sort of have handled the NAND cases, and you sort of have a check saying, hey, these are, the 9 can be replaced by 0, or it's okay to have nines in the system, which is okay. But if you look at the ID column, right, the difference between the first row is and the first row of all other data sets is that one is in caps lock and one is in smalls. Now this sort of join would fail if you're not sort of taking care of the data. And now, so one thing that we sort of handle the way we generally would want to do it is you sort of want to have something called a data validation in middle before even the data actually goes into the join, right? The whole idea of data validation would be to check the pattern of the data that is there. So by default, IDs, let's say ID should be a pattern of number and two letters, right? And they need to be small. That can be one small regex check. You can have checks of, hey, A can be nan or a value. And similarly, you could have B should always be a number, C should always be a number, and F should always be number which can range from minus infinity to infinity. You can add all those checks and sort of then probably do a cleaner join of the data and not lose the data and sort of not mess up the join. So does everyone sort of understand this part? I'm gonna take uh, sorry Manish. uh, all right, so I'm gonna continue with this and come to some of the questions later. mm, all right, so so once you have the data validation in place, it's a lot safer to do the data pipeline join. And now, the kind of data validations that you should be doing is it's not limited, or it's not generic enough, because the kind of data set that you're dealing with can have different meaningful data validations. But a generic test now can be check the values, check the types of the values, check the kind of values that are going into the system. IDs should be unique. There should be not nulls. And if you think about it, all these sort of start coming up, combining into same. Sounds like a rich schema that would actually go into a RDBMS, and it is in a way. And so the reason why this is sort of a problem again right now is in a lot of scenarios, even if let's say the different data sources that you're dealing with and the kind of store that you're creating, uh, they all might follow different standards. And if you're dealing with unstructured data, wherever you're gathering it, it's going to have different kind of impacts. Uh, and so you sort of need to standardize the data that is going into the system before you even actually start manipulating it. So that's the whole idea of doing data validation before before the join in this scenario. Now, I'd like to spend some more time on data validation. And so let's say the first data set that you're dealing with, the next time you start processing it, the values of A are all nans. And what do you think would be the result of it on the joint data, on the final data set that you're creating? So what would happen here is the data that you get on the joint data set will sort of be not usable for the pipelines or the model that you're possibly working on. And uh, there's a sort of a way of how you can handle this situation. Uh, you can actually have a data validation post the whole processing is done, saying, hey, this value should not be all nans. Or you can have type checks again, and you can say, hey, these values should be in specific range. Like, uh, let's just say simple, like B should always be a number, A should not be all nans, and this D and ID should have a particular pattern to it. And you should have X, Y, Z columns in the final data set that you're getting. So you sort of build upon those data validation strategies, and again, they can vary a lot. Sorry, is everyone with me so far? Any questions? Uh, hmm. Aditya, yes, the methods of acquiring the data can be uh, can contribute to the data being bad or ugly. Um, Cordelia, before getting into the pipelines, you'd better Minimal enterprise grade architecture. That is not something that we're covering in this talk, but maybe we can in a future one. And I don't know what enterprise grade means, so in your context, maybe you're coming from a particular problem that you want to solve, but uh, I mean, how to use messaging, pub sub, sharding, indexing, collectivity. So, all right. So most of the engineering stuff is not what something that I'm covering. We are covering only most of the conceptual part. And no, sorry, Manish. All right. Cool. So coming to data pipelines. So once you sort of have created the first data pipeline, your join data, you have validated it, and you know it works before you are putting it to a structure before the join happens, and you are sort of validating the data after the join is happening. Let's say you do it multiple times, right? You would do it the first week, maybe you do it the second week again, and you sort of have a schedule of doing it weekly, and you sort of keep on going from week 1, 2, 3, and similarly further on until someone says that data is not useful anymore. Now the question sort of is the data that is generated the first time on the joint data set and the second time, and sort of that goes to the end time, are they the same, right? Um, Now even if you have checks on your data where you say, hey, B should be a number, column B should be a number, but what you're not checking is the scale of those numbers, right? And even if you're checking the scale of the numbers, in this example, let's say the first time you did the processing, the column B, the joint data that you get after validation also is on a scale of tens and hundreds. And when you do it the second or the third time, the scale suddenly changes. You sort of go into the range of 10,000s and thousands. So what is basically going to happen is the downstream and the end result that comes out of the data, it's gonna change, and it's gonna change drastically. And so you sort of want to keep these things into check because, uh, well, and how you can sort of do it is probably something called data monitoring. It's not the same as the data monitoring that we do with Datadog, maybe. Um, So you want to do data monitoring in a way that you sort of understand how your data is changing over time, so that you can set your downstream jobs to either fail, or maybe you can say, "Hey, I'm not going to press. I'm okay with this kind of data going into the system." You sort of have a check, logical check. And if you imagine a continuous system where you're possibly dealing with terabytes of data, doing these kind of checks, and the cost of just processing one pipeline is going to be a lot. And if this sort of problem comes initially into the system and you're not monitoring it, let's say imagine you just ran a 100 node cluster for 16 hours, that would sort of mean you're approximately, even if you're using the base M4 on AWS, that would still be a substantial amount of money, and all that money would be wasted. And that's sort of the impact of not having data monitoring in place, because uh, well, it's just too expensive if you're dealing with large systems. If you're dealing with small, the expense is going to be small, and possibly you would say you might not even need data monitoring, which is okay. And I guess it can vary based on what the kind of problem that you're trying to solve. So some of the tools that I've used in the past, or using currently, are DQ. So DQ is a AWS project that's built on Spark, and it sort of lets you do the monitoring of the data. It lets you do anomaly detection and multiple various kind of checks that you would want to add generally, and it's open source, so you can use it in any of your Scala projects or create a DSL around it and use it in Python project. Then there's good tables. Good tables generally just deal with CSVs or tabular data, and you can define the kind of schema or the output that you want, and you can actually sort of set up a DIY solution maybe to say, hey, after once I process this data, I want to store these values in a certain store, and when the next time it processes, I just want to compare it to the last time, or maybe compare it to last n times. I hope that sort of makes sense because I'm going to move to the next topic. Hmm. Uh, is there any set of rules this to be followed while data validation? Suyash, yes. Well, depends on what kind of rules that you're talking about. The general, uh, I think, good. So, Uh, there is a link on this slide. You can go and access it. It's basically a whole paper that talks about data validation for machine learning. But this whole concept actually, I think, would work with any kind of data intelligence system that you're trying to build. And what kind of monitoring are we talking about? So the Okay, the kind of monitoring that we are talking about, Dantan, is how you're. Let's take an example, right? You want to, uh, in this scenario, a particular scenario, you want to sort of measure the how the distribution is changing across multiple runs of the data. So, uh, let's say if there is a high distribution change where and you can measure a distance distribution by simple percentiles, like you can capture different percentiles, what the data is at 50 percentile, what's the 75 percentile, what's the 90% percentile, and see if those values are sort of changing a lot. Then you probably have you can say that hey, the distribution has changed and might not want to process the information further. And it can vary across different uh, use cases. Like if you're dealing with geospatial data, you might want to have a check of uh, geofencing, that hey, all values with this particular value should lie in this particular area, and it should not be outside that. I hope that answers the question. Uh, cool. So we sort of want moving to the last section. I'm gonna just open up for questions and discussion after this. So, what happens to the joint data after you've done all these checks, right? So, just a recap, right? We added data validation before put on the input data to put it into a structure where it's usable. Then we processed it, we joined the data, and then we basically added validation in terms of hey, the joint data should look something like this, and then we added data monitoring where it's saying hey, the values from the past run to this run, whether they have changed a lot or not. And now this data is considerably pretty safe to use, and where it generally would go to is uh, a bunch of linear algebra multiplications, which is also called machine learning. And then this goes to the client, for example, or that same join data might go into a different pipeline that goes into further different pipeline, and at the end of it you might have another join data, and that data again goes into another different machine learning system, and that further on goes to the user. Or you have joint data that goes into the system. There's maybe a data mining exercise that you're doing using a machine learning algorithm, and then it further goes into multiple different pipelines, and it goes into a analytical data store, something that you can use to make queries on and see and bring insights. Now, what do you guys think uh, would happen if uh, your data even still goes wrong, right? Uh, I mean, you could have all the monitoring, all the validations in place, but you still can have your client come and say, hey, this output does not look right. What happens there? I'm going to sort of open this up for a bit of discussion before I give the answer. Like, any possible guesses? Yeah. Communication directly is hard on this, so I'm just going to move to the answer here. So, what you would want to do is something called uh, data versioning. Now, what is data versioning? Uh, so, what we generally do is uh, once the whole data is processed, and like let's take the first scenario, right, where you have the joint data that goes into the model, right? What you would want to do is you would create joint data v1 uh, the output of the model, and you use the model output as also v1, and you sort of have a version. And let's say the next time it gets processed, you have the end output, you have a v2, and similarly you can maintain it to three versions in this scenario. And the idea is similar to what GitHub does for code, is doing something similar for the data and the models that you're generating, is make it easier to roll back if something goes wrong, because things go wrong, it's natural. But in a scenario like this, where you sort of have a data set going into a different pipeline, another data set being generated, then going into the model, and probably model sort of working out for the users or the people that are consuming it. In this scenario, again, you can sort of have, like, you can just model the version, you can just version the model itself and not care about this, so that it's easy to roll back. But if you have, I mean, you still have to spend a lot of time debugging where the pipeline failed and what really actually happened, unless you actually understand the whole scenario of what's happening. uh, Now, this case becomes a little more tricky, because let's say you have a dataset that goes into a model, that goes into further pipeline, then goes to generates another dataset, and maybe that dataset again goes back into another machine learning system for data mining, and then a classification. Like, you get the gist of it, I hope. So you sort of have a stream of data processing, data generation, data processing, more generation. Uh, the maintaining versioning in this scenario, like, you have to version each model uh, separately, and each data mining that you're doing, or each data generation that you're doing separately. And it sort of can become expensive if you think about cases where you are actually processing, let's say you're processing around uh, 5 TB of data every week, because that is one of the use cases that we have worked on. And it becomes pretty expensive, and that's where you sort of need to come up with better solutions for data versioning. And currently, sadly, there are not any good solutions. They're mostly custom solutions where you say, hey, I'll store the data in a particular pattern so that I can go back and revert back to the last week's pipeline and results if I need to. And there's a project called dvc.org that is sort of works on it, but it works well for uh, data science projects where you sort of have a static data where it is sort of updated on a less regular basis. Maybe if you're dealing with images, you can store your data and your model. And what DVC generally does, at least for the data side, it's going to create a hash for your data that you can push to Git. So it sort of works well with Git, and it would push your data to S3 or SSH, and it has multiple different supports of where you can push the data. But what we found is does not work all the time. So we are lacking a lot on the data versioning side. Now, so the summary of the whole thing. Uh, what I've experienced is when we're building data intelligence systems, we need to treat data as a first class citizen as much as we treat the code. Uh, and data validation, monitoring, and versioning are sort of some of the things that I think at least are steps in the right direction. Uh, because it sort of gives you a lot more resilience across the kind of things that you might not imagine getting screwed up. If they screw up, you have a lot of things. And if you think about it, we do it a lot for our code bases. Like we have GitHub for versioning, we have uh, CI for managing releases, and then we have user testing. And it sort of I mean, it sort of needs to be done for the whole system, the data also. And that sort of is the last slide. Now it's sort of open up for questions, discussions, and if something that you see is annoying that you want to point out. Again, I know communication in this is hard, but this is where we are at. And probably we could try a different format next time. Uh, Alright, taking the lag into account, I think there aren't any questions. Are there any participants? Fuck, there aren't any. Who we can stop. Oh, sorry, I actually restarted the stream because I thought there are problems with that. Wow, okay. Oh, sorry, I'm just going through if there are any questions that I might have missed. Huh. Thanks, Madhusudan. Okay. Questions that I might have missed. Uh, there's one by Cordelia. This is to be queued. The data versioning slide. How do you get a balance between performance and storage, and what is the better way to ensure source of truth in case of conflicts? Yes, Nipam. Uh, thank you. Sorry, there's problem with the participant list. I cannot see the whole thing. I have to sort of restart this to see it. Thank you, Karan. So, can you explain more on ugly data? All right. So, even to sort of answer your question, let's say if you sort of not have the first step, data validation in process in flight. Now, what happens is let's go back to this slide, right? What will happen in this scenario is even if we sort of have gone through the whole data set and you know that the pre-processing that you've done is true, but the point is that data analysis does not stay true forever. Your data sort of keeps on always changing. And in this scenario, if you look at the data set one that was coming in, it sort of starts showing all land values, which you might not have taken into account while doing the pre-processing. And if let's say that goes into the pipeline and it goes into more bigger pipeline where you have different uh, the data set that you generate is being consumed at multiple different levels. You basically sort of sending in corrupt data, and it you don't know when you're going to notice it, and it's gonna be really one. It's gonna be expensive to figure out where the problem happened and where uh, sort of where you can fix it. Uh, and second is the data that you're generating, like you might not even see the problem, and this has happened, like we don't see the problem until like next 2 to 3 months, uh, and that is sort of the uglier situations where the data sort of becomes ugly to deal with because you don't really know what happened, and since data is sort of always keeps on changing, it's hard to maintain. That is sort of the ugly part of things. um, I can't share exact examples, sadly. It's part of the project, so I'm not sure whether I'm allowed to. Uh, but yes, it. I think it costed us around, uh, like once we when we didn't have it, it costed us around $1,000 just to sort of fix things. And those are sort of the ugly situations where you don't want to get into. I hope that sort of answers your question. And ugly here is not just the data that comes into the system. When we say ugly data, the data is not limited to the input data that is coming into the system. It's also the data that you're generating. I hope I answered the question. Uh, there's other data versioning bit. How do you get a balance between performance and storage? Uh, well, it depends on what kind of data that you're dealing with. We have been so far been able to deal with terabytes of data with just using S3 and sort of a self DIY solution for versioning. And what I've based on what I've talked to different people, a lot of them actually have their own SSD systems where they sort of store the data or sort of maintain a version of it. Oh, yes, Karan, that's correct. This $1,000 that you talked about is just the processing cost, not the time that we bill either. And yes, we during when we were actually fixing the problem, we are not building a new feature, so that is a time loss. Thanks for the clarifications. With data versioning is actually not like a fully solved problem in my head, at least. Uh, it's sort of an idea of what it should be, and I think the balance between performance and storage is sort of similar that we do when coding. Is hey, whether you want the code to be performant or should be space efficient or should it be time efficient. You can't have all of them. So yeah, based on the problem that you're solving or based on the use case, your data versioning strategy should change. Or yes, any other questions? Cool. I will probably wait for another 10 minutes before stopping the stream in case anyone has questions or thoughts or feedback. Hmm. And thank you for joining in. I, yes, we get to hang out here and we talked about something useful, hopefully. No, it's not the Oktoberfest t-shirt. Sorry, it's the same color though. Yes, Murali, the software that we talked about is open source. So there is also another whole topic of which I swept under the rug is data versioning, also model validation. So there is another project along with DVC that helps you do. Uh, I haven't personally used it yet, which is MLflow, which along with DVC sort of helps you maintain a machine learning lifecycle. So maybe if you're checking out DVC, you might want to check out MLflow also. Yes. Yeah, thanks, Karan. All right, I guess that's it for questions. I am gonna stop the screen. Thank you all for joining in. It was sort of nice to do the first online uh, session. You're welcome, Murali. Bye bye, everyone. I'll wait for another 5 minutes before closing it. Thanks, Karan, for sharing that. All right. All right, people. Have a good night. And looking forward to your feedback. I hope you guys learn, I mean, get to take away a few things from there.